Welcome back, you pencil. Today we're doing a practitioner lab from the NoSQL injection section of the Web Security Academy called Exploiting NoSQL Operator Injection to Extract Unknown Fields. Let's read what they give us before we touch anything. The description says, the user lookup for this lab runs on a MongoDB database, and it's vulnerable to NoSQL injection. Our job is to log in as a user called Carlos, and there's a tip. To get in, we'll first need to pull out the value of Carlos's password reset token. That's the whole briefing. No password, no field names, nothing about how. So the plan is going to have to come from poking at the thing. Let's open the lab and have a look. Quick word on setup, because we're using Burp here, and you need it running first. I've got a normal browser with Foxy proxy switched on, and that's what routes my traffic through Burp. Over in Burp, under proxy, intercept is off. Here's the login page. We don't have credentials, but we do have a username, Carlos. So let me just try that with any old password. I'll put Carlos in, type some junk in the password box, and log in. And it says invalid username or password. Fine, that's expected. Imagine if the random junk I typed in would let me log in, and the video ends here. You are not that lucky, little buddy. Now let's go find that request. In Burp, under Proxy HTTP History, there's the traffic I just generated, and I want the post to /login. I'll right-click it and send it to Repeater. Repeater's where I'll work from here. I can edit the request, hit send, read the response, and repeat, without going back and clicking the site every single time like someone with ADHD. Yeah, I am talking about you. Let me look at this request in Repeater. One thing first, I'm switching the request view from pretty to raw before I edit anything, because pretty likes to reformat JSON, and it'll shove my changes onto the wrong line and quietly break the whole thing. Raw leaves it exactly as I type it. Down on the body, we've got a little chunk of JSON, a username, Carlos, and a password, my junk value. This is being sent as JSON, key, and value, which is how the app talks to its MongoDB backend. And since it all sits in the request body like this, not in the URL, I can type these characters straight in. There's no URL encoding to fuss with on this one. Now, in a normal login, the password is a plain string, and the database checks, does the password equal that string? But because this is Mongo, the value doesn't have to stay a plain string. I can hand it an operator instead. So instead of a password of junk, I'll make the password an object, curly brace, $NE, set to invalid, close curly brace. $NE means not equal. So I'm no longer saying the password is this. I'm saying the password is not equal to the word invalid, which is true for basically any real password Carlos actually has. Let me send that. By the way, I am talking about these kind of operators under this video at the top right corner. If you haven't watched it yet, check it out. And the message changed. It now says, account locked. Please reset your password. Okay, a couple of things there. The response flipped it all, which means the app took my $NE and ran with it. So yes, this is injectable. And it came back locked. So even if I somehow knew Carlos's real password, it still wouldn't let me in. I'd have to reset it, which is conveniently exactly what the tip already told us we'd be doing. And notice what the app just did for us, kind of by accident. It handed us two different messages, invalid username or password when things don't line up, and account locked when they do. It's telling on itself. And that difference between the two messages, worth keeping in the back of your mind. So again, always remember, account locked means true. Invalid username or password means false. Before we chase that, let me actually try the front door reset, just to see why it won't work. Back in the browser, there's a forgot password link. I'll click it, put in Carlos, and submit. It says, please check your email for a reset password link. Right. The reset goes to Carlos's email, and I don't have Carlos's email, so the normal path is a dead end. What I actually need is the reset token itself, the secret value that link would carry, and I need to lift it straight out of the database. Just so this is clear, A reset token is basically a long, random string the app generates and quietly attaches to your account the moment you ask for a password reset. It's not something you're supposed to see. Normally, it only ever shows up baked into that email link, so clicking it proves you're the one who asked. If I can somehow read that string straight out of the database instead of out of an email, I can build that same link myself. So how do you read a value out of a MongoDB document when the page never shows it to you? There's one operator in particular that's built for exactly this. Let me pull up the MongoDB documentation, the query and projection operators page, and scroll down to the evaluation section. There's a long list, but the one I care about is $where. Look at what it does. It matches documents that satisfy a JavaScript expression. Read that again. JavaScript. If I can slip a $where into the query, I get to run my own JavaScript inside the database's search, which is an enormous amount of reach for what's meant to be a login box. Let me sketch what's probably happening on the back end, because it makes the rest of this click. I don't have their source, so this is a guess. But a Mongo user lookup like this is probably doing something along the lines of, check it out there, db.user.findOne, and then an object. And that object is basically the JSON we're already sending, a username, a password. When I add a $where to that object, I'm handing the database an extra condition written in JavaScript. And Mongo runs that JavaScript against the matching document, referring to that document as this. That's the key piece. Because the condition is JavaScript, JavaScript is what steers it. So I can write the condition to ask a yes or no question about Carlos's document and read the answer off those two messages we just saw. Let me prove the $where even fires before I get clever with it. I'll keep the $NE on the password so we stay past that first check, and I'll add a new key to the JSON $where, and for its value, a tiny JavaScript function that does nothing but return 1. In JavaScript, 1 is true, so this condition is permanently true. Send it. Account locked. The true response. Now let me change that one to a 0. 0 is false. Send. Invalid username or password. The false response. That's the whole engine right there. My injected JavaScript ran, and I can read its answer straight off the page. Condition true gives me account locked. Condition false gives me invalid username or password. I've got a yes or no channel into the database. Anything I can phrase as a true or false question I can ask, one bit at a time. Real quick ad break. When I started CyberSec, the hardest part was that everything was scattered all over the place. So I pulled it into one library, 33 modules, foundations through SOC and Blue Team. It is on my Etsy, link in the description. The tip wants a password reset token, but here's the snag. I don't even know what that field is called. Field names in Mongo aren't fixed, so before I can read the token, I have to discover the name of the field it lives in. The nice part is, JavaScript will list the field names for me. There's a built-in called Object.keys. You pass it an object, and it hands back an array of that object's key names. So Object.keys of this gives me every field on Carlos's document, and I can pull them out by position, index 0, index 1, and so on. One thing that trips people up here. In MongoDB, every document automatically gets an internal ID field called _ID, and it always sits at index 0. So the real fields don't start until index 1. If you start counting at 0, you'll be poking at _ID and wondering why nothing matches. Let me confirm that quickly. I'll set my $where function to check. If Object.keys of this, index 0, matches _ID, return 1. Else, 0. Send. Okay, let me slow right down for a second, because there's a lot crammed into this one line, and it's worth pulling apart piece by piece, because you are a little newbie noob who needs guidance. The username is still Carlos, so the database still goes and finds Carlos's document. That bit never changed. The password is our $NE not equal to invalid, which is the move from earlier that keeps us past the password check, so the query doesn't just bounce us at the door before the interesting part even runs. Then comes the new piece, $where. and everything in the quotes after it is JavaScript that the database runs against Carlos's document. Inside, there's a little function, and all that function does is ask one yes or no question. Object.keys of this hands us back the list of field names on the document. This just means the document we're looking at right now. And index 0 grabs the first name off that list. Then .match_ID asks, is that first name underscore ID? If it is, the function returns 1, which we already saw reads back as account locked. If it isn't, it drops to 0, which reads back as invalid. And here's the thing, I already know what index 0 is, so I'm not actually fishing for new information here. I'm pointing the whole contraption at a question I already know the answer to, since _ID always sits first, just to make sure the machine reports back honestly before I trust it on the fields I genuinely can't see. Think of it as a calibration shot before the real ones. So as you can see, account locked, so index 0 is _ID, exactly as expected, and the whole setup's working. Real fields start at 1. Now how do you read a field name you can't see? Character by character, with a regular expression. Let me show the match pattern. Caret, which pins it to the start of the string, then dot curly brace, a number, close curly brace, which means skip that many characters. Then one character, in this case x, which is my guess. Then dot star, which means and then anything at all. So the pattern asks, at this position, is the character my guess? If yes, it matches. My function returns true, account locked. If no, false, invalid. I'm varying two things, which position and which letter. Doing that by hand would take the rest of the year, so this is Intruder's job. Let me right-click and send this request to Intruder. By the way, if you enjoy this video, please sub, like, comment, or I will be sad and extinct like this cutie. Now let me actually set this up as a real payload before I hand it off to a machine. Same dollarware trick, but this time I'm pointing it at index 1 instead of index 0, because we just proved index 0 is _ID, so the real fields start one spot over. And inside the match, instead of guessing blind, let me just plug in an actual test. 0 for the position and the letter A for the guess. So this is asking one very specific question. Skip 0 characters, so start right at the beginning. And is the very first character of this field's name in A? If it comes back account locked, great. The first letter is A. If it comes back invalid, it isn't. And I'd try B next, then C, and so on. Doing that by hand for every single position would take forever. So once I've confirmed the shape actually works, this is exactly what I'll hand over to Intruder. 2 positions, one for the number, one for the letter, and let it grind through the alphabet automatically instead of me typing each one in by hand. 2 independent positions means the attack type is cluster bomb. It runs every combination of the 2 lists against each other. First payload set is the position number. Numbers 0 to 20, plenty to cover a field name. Second set is the character guess, brute forcer, a list of A to Z, capital A to Z, and 0 to 9. There I added as a chain of string, and Intruder will handle the hard work for me. I'll leave the string in the description for you, my lazy fish-eyed brother. Now I set the min and max length to 1. Why? Because it tells to Burp that we are trying 1 character long strings at a time. Alrighty, let's hit start attack. Heads up, this is the community edition, so Intruder is throttled. It runs, it just takes its time. By the way, you do not have to follow along in this one. This is only for proof doing that my theory is working. I will let you know when to start to follow again. Normally this is where I'd flip over to render and just read the words account locked or invalid username or password straight off the page, same as before. My render tab isn't cooperating today though, so we're not going to fight it on camera. Good news is you don't actually need it. If you scroll down in Pretty, the same message is sitting right there in the HTML. Account locked, please reset your password, or invalid username. So we'll just lean on the length column instead, since that's already doing the job for us anyway. we are looking for length differences, which aren't the same as the many others. That's our hits. All right, 1 eternity later, this is what I got so far. Okay, at this point, we're already seeing real characters come back. So we know index 1 is genuinely spelling something out, and we already know what that something is. It's username. If you use your enormous logic skills, you can already see it from the letters and the positions, so we do not have to continue this. Because if it is the username field, pretty sure it is not the one for us, which hold the reset token value, which we are after. Same deal would happen if I swapped this to index 2. That would spell out password in the name of logic. Both of those are just proving the theory works, though. They're not new information, and running the full thing twice on Community Edition's throttled intruder would burn a lot of time for nothing. And as you know, I don't like wasting time. Same goes for my bed activities. It tops out at 30 seconds, max. So let's not waste the time. These few characters on index 1 are already enough proof that the mechanism is reading real data. Time to point it somewhere we actually don't know the answer. So let's go with index number 3. Quick checky check if the position parameters are okay and the same as before. Also, you still don't have to follow. I'll let you know when. Okay, this one seems like something with email, so guess this is the wrong field too. We need something token related. Let's go to index number 4. You can start to follow from there. So switch your index to 4. And follow me, my little bud. All right, whew, it took a while. This one's different. It isn't username. It isn't password. Also, not something email related. It's a field name we haven't seen anywhere on the site. Read it down, and there's your reset token field, the one the tip's been pointing at the whole time. Now, one practical thing worth knowing, you do not actually have to sit through the whole character list every single time. Once you can already see roughly where the name is going, based on the letters you've got so far, you can jump ahead and just test your guess directly. The exact same way we confirmed _ID earlier, a single request asking, does this field exist, instead of waiting on the full grind. If it comes back locked, you're done. No need to wait out the rest of the sweep. Let me show you exactly what I mean. Firstly, my cluster bomb attack kind of went through. We got every field we needed, so I picked them one by the payload number order. And as you can see, this is my reset field, which I was after. I want to warn you again that yours will be probably different, so go through this part by yourself too. So in theory, you are not done with your cluster bomb attack yet. And let's say you only have these letters for now, and you are missing like a W and an E. So I delete them from there. What you can do is that we go back to our match ID example and reforge it a little bit so we can testy-test with it. So instead of ID, I go with something like this. So here's the swap. Before, I was doing Object.keys of this, which hands me back the whole list of field names and lets me grab one by its position. But now I don't care about positions anymore. I've already got a strong guess at the actual name from the characters we pulled, so I can just point straight at it. That's what this .pr set tkn is. This is still Carlos's document, and .pr set tkn asks for that specific field by name, directly. And instead of matching a character, I'm asking a simpler question, not equal to undefined. Undefined is just what JavaScript hands back when a field doesn't exist at all. So not equal to undefined is really me asking, hey, does this field even exist on the document? If it doesn't, we can see an invalid output, as you can see there. If it does, because you are a scholar and could do basic inference and you know by the context which letters are missing, the function returns 1, account locked. And I've confirmed the exact name in a single request instead of grinding out the last few characters. Alright, so now we know the field's name. Quick sanity check before I sink time into extracting the value. I found this field name inside the user document, but I'm betting the reset endpoint uses that same name as a URL parameter to check a token. Let me test that. In HTTP history, I've still got the get_to/forgot-password from when I clicked the reset link earlier. So I'll send that to repeater. Let's see. Seems like I made some traffic there. Ah, there it is. First, to see what ignored looks like, I'll add a junk parameter to the URL. Question mark, baby seal, equals invalid. Send. It just hands back the normal page. Baby seal means nothing to it. Sad baby seal noises. Now I'll swap baby seal for the actual field name I exfiltrated. Equals invalid. By the way, my reset field name changed because I got disconnected, so I had to extract it again, and it is different now. Anyways, and this time it says invalid token. That's the tell. The endpoint recognizes this parameter and is genuinely trying to validate it as a token. So the field name is right, and this is the right place to spend it. I just need the real value instead of the word invalid. Back to intruder and the $where attack, because pulling the value is the same trick, only aimed at the value instead of the key names. Instead of Object.keys, I go straight at the field now. This dot, then the token field name, dot match, and the same caret dot curly brace pattern to walk it character by character. This value is going to be longer than a field name, so rather than guess how many positions to grind, let me measure it first. I'll switch the function to ask about length. If this dot token field dot length double equals some number, return 1, else 0. I'll run that as a quick numbers attack over a range and watch for the one number that flips to a count locked. That number is the exact length of the token. So I paste my payload. It should be in the description too, so you can too. I changed to sniper attack because we are looking for one value now. I select a position. Should be okay with the number 20 on the number list. Start attack. And let's wait for a length which is different than the others. There it is. Let's scroll to the answer just to be sure. Yep, account locked. So it is in payload 16, which means our range is from 0 to 15. Now I know precisely how many positions to sweep, and I'm not firing off requests for characters that don't exist. So let me copy the matcher payload, which we talked about before. So I set the cluster bomb back up. Position number from 0 up to that length, what you just got. Character guess, the same A to Z, capital A to Z, 0 to 9, and start. Okay, I can already see something is wrong from the answer lengths. Yeah, internal server error. Not goody good, my brother. Okay, I'm Dumbo. Forgot to replace the field value placeholder with the actual field value. All right, let's copy this, paste it there. Check if the payloads are the correct ones. Of course it is not. Change back to numbers. Okay, it is good now. Check the second payload. Seems fine. And start attack again. Alrighty, baby, seems better. Now 13 million hours of AFK until it goes through. All right, that one took a while. Sort by the length, take the winning character at each position straight down, and the token assembles itself. All right, I got another disconnect meanwhile doing the video, so my new reset field is this one, and here's the value I just got. I'll copy that value exactly as it appears, and again, yours will be different from mine. Now let's actually use it. Back in repeater on that get to /forgot-password, I'll put the real parameter in. Question mark, the token field name, equals, and the token value I just pulled. Send. And now, instead of invalid token, I get a 200. And on render, I can see a page with new password and confirm password fields on it. That's the reset form. The token got me in. One catch. I can't fill that form out from inside Repeater. The lab tracks my actual browser session, so I need this page loaded in my real browser. So I'll right-click the response, choose Request in Browser, in Original Session, and copy the URL it gives me. Over in my Foxy Proxy browser, I'll paste that URL in and load it. There's the Set a New Password form, live in my session now. I'll type in a new password, anything I like, since I'm the one setting it, and submit. And that's the reset done. Now the moment of truth. Let me log in as Carlos with the password I just set. Username Carlos, my new password, log in. And there it is up top. Congratulations, you solved the lab. We're in as Carlos. Let me back up and look at what actually got us here, because this shape shows up all over NoSQL. The password field would take an operator instead of a string, so we dropped in $NE, confirmed the thing was injectable, and learned the account was locked, which is why we needed a reset in the first place. From there, we injected a $where operator, which let us run our own JavaScript inside the query. And the app's two answers, account locked for true, invalid for false, gave us a yes or no channel to read the results off. We used Object.keys through that channel to spell out the hidden field names one character at a time, found the reset token field, then pointed the exact same character-by-character trick at its value and pulled the whole token out. And with the token in hand, the reset endpoint just let us set a new password. No password guessing anywhere. We read what we needed straight out of the database, one true or false question at a time. That's the lab. Leave a comment about your cat's weight. See you in the next one.